Hi, this is Algebra 1, Module 6, Lesson 4, Rabbit Run. Misha has a new rabbit. She is named Weskel. She wants to build Weskel a pen so that the rabbit has space to move around safely. Misha has purchased a 72-foot roll of fencing to build a rectangular pen. So we know it's rectangular, and we have 72-foot roll. So if she uses the whole roll of fencing, what are some of the possible dimensions that she can use for the pen? Let's go ahead. I'm actually going to do these down here, so I've got a little bit more space. So we would have a length and we'd have a width, right? And so what I am going to put up here though is, so if the perimeter, the formula for a perimeter is 2 of the length plus width, right? And that's got to equal 72. Well, if I want to know just a length and a width, I would have to divide by 2 to cancel out that. So length plus width would equal 36. So as I'm figuring this out down here, I'm going to need to know our length. So like if I have a length of 1, my width would be 35, right? Because 1 plus 5 is 36. So then if I had a length of 2, my width would be 34. Length of 3, we'll just go down a little ways, get a width of 33, of 4, we'd have a width of 32, length of 5, we'd have a width of 31, and we'll do one more. 6 is a length of, or width of 30. Okay, so this kind of gives us some options she could do. Probably won't have it long and skinny, but all it says is give some, what are some of the possible dimensions? So we could have those different dimensions. If she wants a pen with the largest possible area, what dimension should she use for the sides? Well, um, let's tack on to this. So if I go from here, 1 times 35 is 35. Next one, 2 times 34 is 68. This one, 3 times 33 is 99, because area, let me back up a moment. Area, just remember, is length times width. So in case you was wondering how I was getting those numbers, hopefully that's review. Okay, so now we have 4 times 32 is 128. 5 times 35 is 155. And then 6 times 30 would be 180. I'm going to add another row. Do I see a pattern as to what's happening to get my width? So to get my width, I had my length. What did I do with that to get the width? Well, I subtracted it from 36, right? Because that was my width. My width has to be whatever the length is subtracted from 36, because they add together to get 36, then rearranging it would be width is 36 minus x. So then to get my area, I multiplied my length times my width. So my area then is x parentheses 36 minus x. So I kind of have a formula now on how to get these. But I don't know quite yet what my largest area is. What do we think it's going to be? I mean, what are some numbers we want to try? Well, I'm going to start a new text box over here. Same idea. Why is it not working for me? Text box, hello. Okay, so we've done 6 times 30. Someone might say, well, half of 36 is 18. So 18 times 18 will be the biggest numbers we can multiply, right? If the length is 15 or 18 and the width is 18, that would get us 324. So if I was going through on these, let's do a 17 times 19 just to confirm that that wouldn't be any bigger. 323. So it's really close, but it is in fact smaller than what we were just looking at. So if we were going to try to convince somebody which size you want to do, take a length and width to multiply. These are only getting bigger until we get to that 18 times 18. So largest possible area would be 18 by 18 pen. So a square pen would give us the biggest area according to these. All right, so write a model for the area of a rectangular pen in terms of the length of one side. Include both the equation and the graph. Well, we just did our equation from that box. So we'll say area of x, let's do a capital A, x equals, and we just said it was x was the length, and then we had to times it by 36 minus x because that was the width. So now we need to do a graph. So I'm going to go jump over to my Jamboard here. And before I do that, look at my different x values. So my length has to at least get up to 36, right? Because that's what we're putting in terms of is length. So I need to make sure my x's get up to 36 because that's the largest possible length you could have if you had 0 width. So kind of, and then my area, it looked like I got up to that 324. So I need to make sure that I at least get up to, say, 325 for my dimensions of my graph. So I'm going to go over here and I'm going to draw. I said my x's had to be my y's. Oop, not being very straight there. Okay. My x's had to get up to 36. You know what? I probably can actually make that longer. Maybe I can go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 35. So here would be 36 right next to it. 40. Good. I can go all the way up to 40. Nope, that was 5. Scroll down. Nope. So 5, 10, 15, 20, 25. Oh no, I was off. Can't do those. There's my 5, 10, 15, 20, 25, 30. This is my length. Here's my area. And so 1, 2, 3, I think I want to go by 4s on this, by 25s. So 1, 2, 3, this would be 100. Of course, I could maybe go by, I think I would get to 300 pretty quick. Maybe I could go 1, 2, 3, 4, 5, go by 20s. 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300. Okay, so as I'm going through here, I had my new 18 was 324. So if that's 20, I'm going to go up just a little bit above it to be 324. I know 17 was at 323, so it was really, really close to that, but again, a little bit lower. One higher would also be, let's go back to here. If I continued this, I would be doing 19 times 17, which then would go back to that 323. So I notice that that's kind of a high point in there, and I'm going back down. So let's see, 3 and was 99. So let's find that one. So 3, 1, 2, 3 would be really close to 100, which means, excuse me, 33 would be really close to 100, because that would be those just backwards, right? And then what's another one in here? Oh, 180. 6 is 180. So let's do 6 and 2040. That's on the line. 80, which means 6 times 30. So 30 would be 180. So I'm noticing with this line, 0 is going to be 36. No, 0 is going to be 0 because you're going to multiply anything by 0. And then I'm going to reach up here. I'm going to come down right at 36, right? Because 36 times 0, make that just a little bit more accurate. There we go. So this would be my options on there for my graph. So that's what that looks like. So it's an upside down parabola in this case. All right, so I did my equation in my graph. What kind of function is this? Well, what kind of function do we have here when it makes that kind? Well, this function is quadratic. Quadratic. All right. Because it graphs as a parabola. And if we took at our differences up here, we subtract these two, 68 minus 35 is 33. 99 minus 68 is 31. 128 minus 99 is 29. Notice how when I'm doing these, 155 minus 128 is 27. My second difference is a minus 2 on here. So it's a parabola, and the second difference is constant. All right. How does this function compare with the second type of block I logos in I rule? Okay, so let's make up a little bit of a table here. Makes it easier to do these. So we have this one, which is rabbit run. How does this compare to I rule? Okay, well, first difference in this one was linear, and that was the same for I rule. What about the second difference? Well, it was constant, we just said. And I believe in I rule, it was also constant, right? Because it was quadratic, the big block ones anyway. How about the graph? Well, this one is increases, then here, decreases, has a max, and over a little bit, run out of space. The I rule, if you remember correctly, increased and had a minimum. Remember, it was just going up. Right? What else can we compare? Equation. Let's look at the equation. The equation was, let's see, this one has two linear factors, which, if we would multiply that out, would be an x squared, right? And this one had an x squared term. So they both had that. One last thing, slightly different between the two of them. I'm going to scoot that over so we have room to see it. I'm just going to put on here the line. So here we would put continuous for it because you could have 1.5 feet by 34.5 feet. You could do a 18.2 and 17.8 on there. So you could have partial fences. As far as the I rule goes, though, it would be a discrete graph because you would not necessarily about 9 dots. All right. Because you were working with solely, you either used all the square or you didn't. So therefore you couldn't have half a square, 1.5. All right. Thanks for joining us. And that's all we have for this one today.